Hello, am I audible? If I'm audible, then in the chat box, please type yes. Am I audible? Okay, fine. Then let's start. Hi, hope all of you are alright. So now, as you know that we were instructed to take some online classes, interactive classes. I think this is the better way of doing this thing. So first of all, I will like to say you something about how we can interact with each other. You can see that when this live streaming will go on, you can write your queries into the live chat. So if you have any query that arises due to the discussion, then write it in the live chat box. And another thing which has been raised is the question of attendance. As you know, we teachers are fond of this attendance thing. So I have figured out something by we can prove that we were available during this interactive sessions. Just you do one thing, write your name and university roll number into the chat box. Now, once this is over, the session is over, then I can count and figure out whom of you were present. So let's give it a try. Uh, Once this live session is over, I will upload the video in the YouTube. So for your future reference, you can watch it there as many times you like. Now today, let's go back to discussion. We are going to study transformation in 2D. I think we have discussed something about this during our classes before the lockdown. Uh, let's we do it once again. So when we say transformation, what sense do you have in your mind? Just give it a thought. And before starting the technical discussions, I will like to show you some animations. Uh, Here you can see that in my browser I have opened a website. You can go in there and play around with the things. Now just look at them one by one. Just look into this animation. What do you think? What kind of transformation is this? Just write into the chat box. Think for a while. This is a two-dimensional plane. You can see the x-axis goes like this, and vertical one is the y-axis. Then you have a triangle, and some movement is going around in the diagram. And what kind of transformation is this? Just think a little while and write down the answer into the chat box. Rohit, Mirror image, that is reflection, right? That is reflection. Let me move on. You can see that here we have another instance of reflection. During the previous case, it was reflection of a triangle with respect to the y-axis, and into the second figure you can see that a point is being reflected with respect to the y-axis. Now let me explore other diagrams here. What kind of reflection is this, and what are the parameters? Just think for a while. It is again reflection, but now some parameter has been changed. Think for a while and write the answer into the chat box. This is reflection with respect to the x-axis. Now let me move to the next diagram. Here you can see that reflection is being happened with respect to some arbitrary line. You have a line whose equation is y equals to x, and this point is being reflected with respect to this arbitrary line. Now move on to the next diagrams. Yes, something same is going on. Is the previous one? Yes. Now come to this diagram. Here you can see reflection, actually composite reflection is going on here. First, reflection is done with respect to the y-axis. Then reflection is being performed with respect to the x-axis. Okay, now look into this diagram. Think for a while and write into the chat box, what kind of transformation is this? Give it some thought, observe the diagram carefully, just do a little brainstorm and write down the answer. Okay, I hope you have some ideas in your mind. This is basically rotation of a triangle. You can see that the triangle ABC is being rotated by an angle of 90 degree in anti-clockwise, that means positive direction. Then come to the next diagram, this one. In this diagram, this is basically an example of translation. You can see that triangle ABC is being translated. You can observe the linear movement here. Then let me move on to the next diagram. Yes, here you can get a better understanding of the translation phenomena. You have a point 3, 2, this point A, and you have to translate this point by an amount of -1 and +2. That means, just observe the animation. At the beginning, what happens? The point A is being translated along the x-axis by an amount of -1. Then along the y direction, it is being translated by +2 amount, and you get a new point A dash. So if you have observed these diagrams carefully, Now you have some idea about this transformation phenomena. So just do some brainstorming and try to figure out what is the purpose of this transformation and why you need this to be embedded in your computer graphics algorithms. And let we move on to our main discussion. Uh, yes, here is it. Basically, in computer graphics, what happens? Various transformation techniques are there, right? You might have studied some of these transformations during your high school maths study. Now you have to figure out the algorithmic approach for these transformations. How you can simplify the calculations for these transformations so that a computer programmer can easily embed them in computer programs. Basically, transformations in computer graphics can be of this five types: translation, then rotation, then scaling, then reflection, then shearing, shear transformation. So today we are going to study about translation and some mathematical approaches that you need to apply to simplify the formulation of translation. So how translation goes like, you have had some idea about that from the previous diagrams. Just once again look into the translation phenomena mathematically. You have a point x old and y old. Then you have to translate this point x old y old by an amount of tx and ty, right? So what you will actually do here is you will add tx to this x old and ty with this y old. By adding this, actually what trajectory you are following? You are following something like, at first you are moving tx amount in the x direction, then you are moving ty amount in the y direction, and you arrive at a new location, which in this diagram you can see that has been noted by this O dash. So can you figure out what is going to be the coordinate of this O dash? Write it into the chat box. Once you apply tx and ty amount of translation to this x old y old point, what will be your new coordinate? This one is your x old y old. And you are applying tx and ty amount of translation to this point. Then you have to find out the new coordinate value. That is the question. Say it is x dash y dash. Hope until now you have had some ideas in your mind about the new coordinate values. Now I'm going to write it here. X dash is going to be equal to X old plus Tx. Here is your X old, and with this X old you are adding Tx to arrive at the new X coordinate for this O dash point. Similarly, Y dash is going to be Y old plus Ty, right? So this was the basic starting point of translation. Now let us look at the mathematical statements. Initial coordinates of the object O is X old, Y old. New coordinates of the object O after translation is X new, Y new. Translation vector or shift vector, that means the amount of translation you are going to apply, is Tx Ty. Now, given the translation vector Tx Ty, Tx defines the distance the X old coordinate has to be moved, as you have observed in this diagram. Tx defines the distance the X old coordinate has to be moved. Similarly, Yt defines the distance Y old coordinate has to be moved along the Y axis. So now this was the brute force calculation or mathematical calculation for this translation phenomena. Now, how you can simplify this formulation so that you can simplify the algorithm development procedure. So here it goes. X new equals to X old plus Tx, and Y new equals to Y old plus Ty. So if you transform this equation into matrix format, it becomes like this. You can see that the new matrix X new, Y new equals to old matrix X old, Y old plus the translation vector Tx, Ty. Now at the next statement, you can see one line. Just read the line carefully. The homogeneous coordinate representation of xy is xy1. Now, what this homogeneous coordinate is? First question. The second question is, what advantage you will have by converting everything to homogeneous representation? For the second question, the answer is given here. Through this representation, all the transformations can be performed using matrix vector multiplications. How? If you look into translation, then you can see that this translation phenomena has been represented in addition format. Or so if you want to program this thing, you have to implement the addition operation, right? Then just take one example of reflection that you have observed. Say this is your x-axis and this is your y-axis. Here you have a point x, y, and you have to reflect this point xy with respect to the y-axis. So once you reflect this point xy with respect to the y-axis, what is going to be the new coordinate values? X dash, y dash. So what is the value of x dash in terms of x? You can observe that it is minus x and y dash is y. So you can see that in case of reflection, this was an example of reflection. The operation or nature of operation is something other than translation. In case of translation, you had to add the translation vector with the original point, but in case of reflection, you have to multiply one coordinate value with -1 and another coordinate value you have to written as it was. So you can see that for different transformations, the calculation approach is different. So by using this homogeneous coordinate method or homogeneous coordinate system, everything can be represented in matrix multiplication format. Now let we study something about the first question. That means what actually homogeneous coordinate system is. For this, let we go to this diagram. Just look into this diagram. This is a railway track, right? If you observe, we all know that railway tracks are parallel to one another. So in Euclidean 3D space or in Cartesian coordinate system, these lines will be always parallel. At least from our mathematical knowledge, we know that thing for sure. But think of someone who has never seen a railway track and today is observing a railway track for the first time. So how he or she will perceive this thing? He will think that these two lines are basically converging somewhere at infinite. In other terms, these lines are parallel. That means from the viewer's perspective, not from mathematical perspective. What happens? Railway tracks are actually not parallel, at least from vision system. They merge with one another at the horizon. So how you can formulate something by which you can represent both the things together? The answer is homogeneous coordinate system. And how it goes like? Just look at the statements in Euclidean space geometry. That means the Cartesian geometry we use in our day-to-day life. Two parallel lines on the same plane cannot intersect or cannot meet one other forever. However, it is not true anymore in projective space. Projective space means how you observe the things. the space where you perceive the things, where you feel the things. For example, the train, railroad on the picture becomes narrower while it moves far away from eyes. Finally, the two parallel rails meet at the horizon, which is a point at infinity. Okay, leave it. Now, just look at this part. What is the coordinate of a point at infinity? The point at infinity has a coordinate infinity, comma infinity, something like this. And in our Cartesian space, this representation actually doesn't make any sense, right? But as it doesn't make any sense to our perception, is it really true that the point has no coordinate representation? The point actually obviously has some representation. So a point at infinity becomes meaningless in Euclidean space, or more precisely, the Euclidean space representation becomes meaningless somehow in algorithmic terms. So to understand these things in clear terms, just look into these two equations. Ax plus by plus c equals to 0. Ax plus by plus d equals to 0. So can you tell me the nature of the lines? Are they parallel to each other, or are they perpendicular to one another? Just give it a thought for a while and write the answer into the chat box. Okay, these lines are basically parallel to one another. And if in this equation C becomes equals to D, then two lines are going to be identical. Why? Because if C equals to D, basically these two lines will represent the same equation. So if you follow this equation system, the two lines will look something like this in your 2D space, right? Say this is the first line. We call the first line as line A, and we call the second line as line B for the time being. This is your line A and this is your line B, and the perspective is Cartesian coordinate system or Euclidean space. So if you follow the equations and their graphical representations, one thing is obvious, that this representation does not justify this convergence of parallel lines at infinity or at horizon. I think this gives you a sense, and if you have not been able to realize or perceive the situation, just later on give it a thought and try to figure out what you have understood. In this representation, you can see that if you go towards infinity, the infinity is somewhere outside my computer screen. this lines are actually not going to converge anywhere, right? So how you can develop a representation methodology where the original nature of the lines will be preserved, as well as you can find a solution for the equations, or represent the fact that at infinity the lines are going to converge. Just as a matter of fact, before some time we have told that at infinity the coordinates for the point should become infinity comma infinity. Just keep this in mind. Okay, now here is the solution. Just look into the solution. What you are doing actually, you are rewriting the equation like this. You are writing the equations for projective space or perspective space by replacing x and y to x over w and y over w respectively. You see, what you are doing is actually you are dividing x and y by some scalar value. So only scaling is going to happen and no change in perspective should happen. So how this thing can be imagined, say this is a triangle, you are looking into your computer screen and from 1 feet distance. Okay, now if you move 10 feet away from your computer screen, just observe carefully. You for the time being is looking onto the triangle onto computer screen from 1 feet distance, right? And after some times what you have done is you have been moved away 10 feet from your computer screen. Now your triangle will appear smaller to you, but other nature for the triangle, its coordinates, everything will be same with respect to the computer screen, right? So the same phenomena is going to happen here once you divide x and y by this scalar value w. So now your equations become a x over w plus b y over w plus c equals to 0, and you are doing the same thing for the b equation. Now to reduce computational cost, what are we doing? We are omitting this division operations, and it is simple. Just multiply both sides of the equations with w. Now your equation becomes something like this: ax plus by plus cw equals to 0, ax plus by plus dw equals to 0. Now look into this equation, and compare this equation with the previous one. Just compare. If you compare both the equations, you can find that in this particular case you are not going to get any solution for the equations, right? You are not going to get any solution for the equations. Minus 0, 0, c minus d equals to 0. If you try to solve these equations, you will arrive at something like this, which basically doesn't make any sense, right? Now, what you have done in case of homogeneous representation, you have introduced a third variable w. Now, with the arrival of this third variable, you can see that the situation is changed and you get one solution at this instance. How? Let we calculate the solution for this two equations, like previous one 0 0, sorry, then here you have CW minus DW equals to 0. So what is the value of W? W is going to be 0, right? If you solve these two equations and try to figure out the value for W for these two parallel lines, the value of W is going to be 0. Now, the subtle point to observe is that in the second case, you have represented your parallel lines by using 3 tuples rather than 2 tuples. In the first representation, you had only x and y tuple to represent your parallel lines. Now, in the second case, that means in homogeneous represent case, you are representing a point on the lines by using 3 tuples x, y and w, and the w for the parallel lines you have calculated is 0. Now you can see that this representation of a point at infinity and infinity becomes justified. How? It's simple. If you look at the representations, when you represent a point onto the parallel lines at infinity or so anywhere, it is represented using xy in Cartesian coordinate system, and in homogeneous representation it is xyw, and the mapping system is x over w, y over w. Actually, these things you have done in these two equations. This one is the homogeneous representation and this one is the Euclidean representation. Now say you have a point 1, 2, 0 at infinity with respect to your homogeneous coordinate system. Now what is going to be the corresponding Euclidean values for this coordinate? Just give it a thought for a while and write down the answer into the chat box. If you have followed the discussion, hope you might have come up with some solution. The solution is simple. The coordinates for the point at infinity is 1 to 0 in homogeneous system. So their corresponding Euclidean representation is going to be 1 over 0 and 2 over 0. So now you see that you have been able to arrive at this infinity coordinates by following homogeneous to Euclidean mapping. So from the computational or mathematical perspective, this homogeneous representation makes sense. While you have represented the point using Euclidean space representation system, you cannot do any mathematical operations with this infinity values, right? You cannot do with any mathematical calculation with infinity. But once you translate entire thing to homogeneous representation, you get a finite representation of the same point. Now, as the values are finite here, you can apply any kind of mathematical operations, algorithmic operations to these points. So this was the idea behind homogeneous representation. Just another look at the points. Say you have a point 1, 2, 3 in homogeneous space, and the corresponding Euclidean representation is going to be 1 over 3, 2 over 3, x over w, y over w. This is homogeneous representation. X, y, w, homogeneous representation. Sorry. This one is homogeneous and this one is Cartesian. Now look into the next point. It is 2, 4, 6. Now convert it into Cartesian representation. It is 2 over 6, 4 over 6. Then 4, 8, 12 in homogeneous space or perspective space. And when you come to Cartesian space, you have 4 over 12, 8 over 12. So you can see that from the viewer's perspective, the points are different. But in Cartesian perspective or Cartesian coordinate system, all 3 points actually represent the same point, as we have discussed sometimes before. A triangle which is on your screen will look something when you look at it from 1 foot distance, and it will look like something else when you move 10 feet away from the computer screen. That thing is obvious into this mathematical notations. In homogeneous coordinate system, you can see that representations are different, but in Cartesian system, representations are same. Now let we go to our translation phenomena or translation algorithm and convert it into homogeneous coordinate representation. The homogeneous coordinate representation of a point xy is xy1. Now, why you have introduced 1 as homogeneous value in this system? By using 1, you are actually implying that your homogeneous coordinate system and Cartesian coordinate system both are basically same. You can see that if you translate this homogeneous representation to Cartesian representation, it is going to be x over 1, y over 1, that is x, y. So by introducing this homogeneous representation, the other advantage you have achieved from the perspective of algorithmic development is that now you can implement every algorithm in terms of matrix multiplication, and you can generate some universal constant matrix representation for this uh, different transformation phenomena. You can see the calculation here. Here is your translation matrix. This is the translation matrix. So now the question is how you have arrived onto this conclusion that this is the translation phenomena which is going to happen in algorithms. Let me do the calculation. Just at first draw the points, so xy, then translate it by an amount of x and ty. So this is your tx and this is your ty. So x dash becomes x plus tx, y dash becomes y plus ty. Now this is the Cartesian representation. Now add the homogeneous coordinate to this representation. 1 equals to 1. Now you can see that we have not manipulated this one thing. Why? Because this was our assumption. That means before transformation or translation, our coordinate is xy1 into homogeneous space, and after translation it is x dash y dash 1 into homogeneous space. Now try to convert this thing into matrix representation. Do one back calculation, and it is something like x dash y dash 1 equals to 1 0 tx 0 1 ty. Lastly you have 0 0 1 and multiply this matrix with x, y and 1. Say now if you solve this equation, you will find that you will arrive at this conclusion. So how? X multiplied with 1, y multiplied with 0, 1 multiplied with tx. So you get x dash. For y dash, x multiplied with 0 plus y multiplied with 1 plus y multiplied with ty, and you arrive at y dash. Lastly, 1 multiplied with 0 plus 1 multiplied with 0 plus 1 multiplied with 1. That means 1 equals to 1. So you can see that you can represent this translation phenomena using this matrix multiplication, and this is your translation matrix which you need to multiply with the original point. So what is the advantage in terms of algorithm development? Now see, you want to develop a computer program which is capable of doing this translation thing. Now try to figure out what you need to provide to the program after once you have implemented everything. You need to provide the original input point, and you need to provide only the translation amount. You don't need to do any addition, any subtraction, any multiplication or anything like this. Just everything will be taken care of by this multiplication thing for all the transformations. So this was your translation in homogeneous coordinate system. Hope you have been able to understand the concept of translation and homogeneous coordinate as well. If not, then later on watch the video once again, take a notebook and take notes wherever you think necessary. Now look into these two problems involving translation. Problem 1 goes like, you have a circle C with radius 10. So what does it say? It says that you have a circle C with radius 10. The radius of the circle is 10. Then coordinate of the center is 1, 4. That means the center of the circle is located at 1, 4. Then you are being told to apply the translation with distance 5 towards x-axis and 1 towards y-axis. Obtain the new coordinates of C without changing the radius. So how to do this? You see, the equation of circle is x minus x coordinate of the center whole square plus y minus y coordinate of the center whole square minus radius square. So this was your original circle. Now you are being told to translate this circle by an amount of plus 1 towards x-axis and by an amount of 1 towards y-axis. So your approach should be something like this: x equals to 1, y equals to 4. You need to apply translation tx along x-axis and it is equal to 1. You need to apply translation by an amount ty which is equal to, oh, sorry, I have done a mistake. It is basically 5. Yes. So this is your translation vector and this is your original point. Now obtain the new center of the circle after translation. X dash y dash 1. How you can do this? Just input the translation matrix into the system, and it was 1 0 tx, which is 5 in our case. Then 0 1 ty is 1, you can see, as it has been mentioned into the problem. Then just append the homogeneous 1 to the matrix, and here is your translation matrix ready. And you need to multiply your original point, that means original center of the circle, to this translation matrix 1 4 1. So once you solve this problem, you will find the value of x dash and y dash. Eventually x dash will become 1 multiplied with 1, 4 multiplied with 0, 5 multiplied with 1, 6 if I am not wrong, and y dash will become 4, 5. So your new center for the circle is going to be at 6 4. Now assume the circle which has a radius of 10 around this new center 6 5. So your new circle after transformation is x minus 6 whole square plus y minus 5 whole square minus 10 square equals to 0. So you can see that from the mathematical derivation we have arrived into some conclusion. Now let me check if our observation is correct or not from manual translation. You are told to translate by a distance of 5 towards x-axis. Now before translation the x coordinate for the center is 1. So once you translate it by a distance of 5 along the x-axis, the x coordinate for the transformed center is going to be 6. 1 plus 5 equals to 6. Again, you are told to translate by an amount of 1 towards y-axis. It is something like this. Now you will move into y direction by an amount of 1. That means now you are adding 1 to 4 to get the y coordinate of the translated center point, which is 5. Now you can see that the conclusion what we have made by the algorithm is same as the conclusion which we can figure out from the mere observation. So this was the translation thing in transformation in 2D module. Hope you have been able to learn something. As you know, there are internet problems. And when you learn something from home, proceeding following this kind of method, some difficulties you have to face, that is true. So what you have to do, you have to give it your time. Whenever you are convenient, then do one thing: watch the video carefully. At first, as I always say, read the document, then watch the video, then read the document carefully once again. Whenever, wherever you find problems, just jot them down and go back to the portion of the video where it has been discussed. If you give it some number of tries, so you have to watch it for 2 times, 3 times, then surely and obviously you will able to grab the concept. That's all for today. Stay safe, stay home. Have a good day.